Hi class, for this section we're going to talk about, or we're going to actually review polar coordinates and equations. And here's the idea. So for any of the problems that we're going to be actually working with once we start, doing calculus with polars, you're going to have to reference to the following formulas, and basically that's all the ones that you have here. And remember that when you're talking about a polar coordinate plane, you're basically dealing with circles. This is technically 1, 2, 3, and so on. And all of these revolve along some sort of an angle. So you have here the relationship, or basically if you're looking at x's and y's, how to plot them. Remember that these are coordinate points, so you just end up plotting a basically dot on the actual axis. Now here's the idea for the first couple of problems. Now all I need is a basic sketch, and you don't have to recreate this mess over here, as long as it's approximately where the coordinate point is supposed to be. That should be fine. So we're looking at the following. So for this particular one, they want us to plot and then express it as a rectangular coordinate. This is 3 pi over 2. So technically, it's going to be a dot on a circle of radius 3. So that's where all these circles are actually coming from. And then at an angle of pi over 2. So for any of the sketches, it's sufficient to just estimate where the circle is going to be. In this case, your radius is 3. So that's going to be 1, 2, and then technically 3. Not to scale. I should probably adjust it a little bit more. But that is 3. And then your actual angle, it's at a pi over 2. So technically, that would be the coordinate point. So in terms of r comma theta, this coordinate point is 3 comma pi over 2. And it basically represents a coordinate point on, at an angle of pi over 2 on a radius, or on a circle of radius 3. So technically there is a circle, obviously not to scale, but this will be technically 3. This is also negative 3, but a distance of 3, and then 3. So for this one, you just need a dot for the representation of the coordinate point system. Now, some of the problems, they may just want you to provide a dot on the approximate coordinate point, and then they're going to want you to express them as rectangular, or for some of the equations, they may want us to express them as rectangular equations. So in order to express them with a rectangular coordinate point system, you're going to use the formulas. In this case, we're talking about, these formulas. Your x is equal to r cosine theta, your y is equal to r sine theta, and that will actually do it. So in this case, your x value is equal to r cosine of theta, your y value is equal to r sine of theta, and in this case, we're looking at 3 cosine of pi over 2, and this is equal to 3 sine of pi over 2. So we're going to end up with, technically 0, and then this is 3 times 1, which is 3. And then our main conclusion on this example is that if you're expressing a problem in polar coordinates, in this case r comma theta, which represents on this one 3 comma pi over 2, this as an x and a y happens to be the same coordinate point as 0 comma 3. So that's the main relationship that they want us to look over this problem as we review it. It's just a different way of expressing equations. For what we're doing in our class, it may be easier to do in some problems, derivatives or integrals with polar as opposed to rectangular. But that's it for this example.